All right, before we move on to analyzing these light effects on shapes that are not spheres, on more organic shapes, I just wanted to go over very quickly the effects of the other kinds of light sources on these. So that's the point light and the soft light. So we won't elucidate the many parts of the light like we did on the base demonstration, but just to show the differences that occur between these lighting scenarios. So let's put a point light over this one and let's get it pretty close to really emphasize what we're trying to show here. So here's our light bulb. And this will be emblematic of a point light. And we will put a softbox light, or we can imagine like a skylight, over this sphere. And we'll make it very big and also pretty close. So this could be anything: a window, a skylight, a photographer's softbox, anything there. So on the point light, both of these situations create all the same parts of the light that we went over in the first demo. All you need to understand is different for the point light is, like we already explained, the point light emits light in all directions, except where it's plugged in. So we have to imagine that the tangency on the point light, if we go from the center of the light, the tangent point on the point light, and thus the core shadow, is going to respect the fact that light is coming from the point in a cone shape in respect to the ball. So if you imagine drawing the photons, that always makes it very clear. So all of the photons that are going to be hitting the ball directly are going to be within this triangular shape. And actually, this is going to all be shadow, the cast shadow. So unlike our cast shadow under the sphere that was under a perfect directional light, like a spotlight or the sun, which has parallel light rays, because the light rays from a point light are not parallel, the cast shadow is wider than the sphere, which makes it a little more dramatic. And that would be, this would be the lighting situation that you would have if you were doing a drawing or a painting and the light source was, you had a figure or anything, your subject, in a room that had no other light but a candle or a fire or a single light bulb. And you can imagine someone holding a candle with no other light in the room, or being around a campfire. Those shadows get very dramatic, and this is why they always become larger than the actual subject. And then this also means that the terminator, the tangency point, is higher on the sphere with a point light directly above. Right? We can see where the light rays graze the surface is very different from where they are when the light is overhead but is a perfectly directional light. So in a point light, in the same position as a parallel directional light over a sphere of the same size, the shadow side is going to be much bigger than the light side. There also tends to be a little less fill from the table, because as you can see here, there's no light rays hitting here, right? In these triangles. So this is no light rays hitting in those triangles. That means that the photons that are producing the reflected light, as you remember, that are hitting other things in the environment, they're actually coming from further away than the environmental photons in the overhead light. situation. So they're striking the table because the cast shadow is wider. They're striking the table farther away from the subject. And so they're losing more energy as the bounced light travels up to the ball. So another thing that happens in a point light situation is that the reflected light is less intense than the reflected light in a directional light situation. In reality, there's enough other variables going off in a real scene that this rarely happens. This is a result of just like a very focused studio situation with truly like just a dark background, no other ambient light, and just the one light. But that would be the case. But in reality, it's very rare that it would ever be noticeable that that's the case. But yes, it changes the traveling distance of incident environmental light to have the light cone creating a wider cast shadow and a larger area without direct striking of light around the subject. So that's what you want to know about point lights. And you can imagine if this goes all the way up, if it goes higher, higher, higher up, as that point gets higher and higher up, that cone gets a little more opened up until you can imagine if this light bulb was strong enough and was super, super far away, it would actually start casting beams that are almost parallel. And then that's how we can arrive at the sun, a point light that is far away enough and huge enough that even though it is actually shooting light out in all directions, by the time it hits the Earth, if this was the Earth, they're basically parallel. And this is the area light. So what you want to keep in mind about the area light is that the diffusing screen, for example, on a photographer's box, or has the same effect as something like the diffuse light that comes in from a window that does not have direct sunlight coming through it. So if you are looking at a window, there's no direct sun coming in, it's still quite bright. There's a lot of light coming in, but it's coming in from the diffuse sky dome in the environment. It's coming in from just the sky itself emits a lot of light. Light from the sun, which is super intense, is hitting particles that are everywhere in the sky and in the atmosphere, and it's scattering photons everywhere. So the light is a light source that every bit of it is just shooting light in all directions in a diffuse way. And that's why overcast days and open shadows, even on sunny days, have so much light in them. You can still get a lot of color, you still get a lot of detail. A diffusing screen on a photographer's softbox does the same function of scattering and shooting everything around, right? Like, because if this was a photographer's softbox, let's say, without a screen, a diffusing screen, this might just instead, there might just be 3 point lights behind the diffusing screen that would make it, that might be what's actually inside the photographer's light box. And then that would just become doing the math of 3 point lights, which is not what this situation is. It's the point light situation going through, it hits the screen, and then when it hits the diffusing screen, the light comes out like this. Much more varied, bouncing in all directions. And then this is why it looks soft. It's not clearly defined, and it does not produce harsh shadows, because you can see with all of these light photons scattering all around, this would produce one Terminator if we mapped it like this. This would produce another Terminator. This would, it doesn't even go anywhere near it. It's coming in at all these different angles. So you could never, on every point of the sphere, there's going to be some photon that's hitting the edge tangent there. So you really can't decide anywhere. And then that's why you get a true soft gradation in a nice softbox situation where it's really mostly the occlusion, right? Like as the form turns away this much, there's very few parts of the softbox, right? Like literally, like down here, this point on the sphere, right? Can anything from this left side of the softbox, can anything from this left side of the softbox ever hit that point of the sphere, no matter what random way it comes from? No, There's no way, right? So this part gets no effect from this whole part of the softbox. Same with this part. Doesn't get anything from the right side. But this little lip, this part over here of the softbox might cast some photons that can hit it. So it's not completely dark, right? You're going to get the complete dark still down in the contact shadow where really things are bouncing around like crazy. But it's going to shade away as a smaller and smaller part of the light can affect that particular point on the surface. So it creates a very soft gradation and very even light everywhere else on the sphere. And very little value change is going to happen because it would take a very strong plane change to get a defined and contrasty value shift, because small bumps, undulations, organic forms, they're always going to get filled in and softened by these light rays that are just bouncing from everywhere. The cast shadows in soft light situations get very, very diffuse. Let's say the cast shadow is denser there and it gradates away, still with a crisp contact shadow. And they can produce effects like penumbras, which are linked to this effect again, right? Usually a smaller light source reveals it more than a true soft light source, but you can imagine like a fluorescent light tube or something like that. It is going to have this same effect where the furthest extents of the tube are only have access to certain parts of the form, and thus you get shadows that look doubled or tripled even if there's only one light source. That's a penumbra. So there's other, pointed effects like that, but this is the gist of these more specialized lighting situations and what you want to remember them. But for the most part, when we're thinking about our modeling and our rendering and how we're going to shade things, we are going to make some concessions to this, especially in the cast shadows for, if you have a scene that really has a strong point light source in it. But when you're actually modeling on the form of your subject, most of your thinking is going to revolve around what happens with the directional light. Usually these effects are, especially if you're making things up, it's very difficult to sell these convincingly. And even from a reference, the reference will give you the light shapes and the light areas to make this convincing. It really mostly hinges on the shadows. And when you're rendering your form, you're really just going to think about directional light photons and the basic way that the forms are bending away from them. But this is the gist of point light and soft/diffuse.